Now then, it's blowing a gale outside, so you might hear some background wind noise, but we're in the workshop. I picked up this Qualcast lithium ion battery a few days ago. Interestingly, it's got vents in the bottom, but I will investigate that at some point. What's the bet in that it's the battery management board that's packed up? Anyway, yeah, we've got this Ginlong 6 kilowatt turbine grid inverter here. I know it's faulty, and there were 3 in amongst that pile with the Aurora inverters in it, and there's another 2 down there that are in bits. But basically, let's investigate this one. I've taken all the screws out the bottom to start with, just because I found some of them, the screws are particularly poor quality, and they're unusually tight. So some of them I had to actually get the cold chisel to get them to free them off, because it's the heads of it's a torque head, but they're stamped and they really don't grip that well. So there you go. So let's crack on with this. So I'll just turn this round. Okay, and all the screws are out, as I said. So we lift this up, and all the connections are on this end. Let's just see if we can zoom in a bit. So we've got this ribbon here which unclips. That's the ribbon off. Then there are 2 communication sockets there, and they're identical, so I'm assuming it makes no difference which way round. Then we've got the DC here. We've got 2 DC positives and 2 DC negatives, and then we've got the mains here. Again, 2 lives and 2 neutrals, and it's all marked on the board, so you've got no fear that you're going to get it wrong. Now all of these have got a lock on them, so you've got to press in there to get them off. So I'm not going to let you watch me struggle to do these. I'll get the snipe nose pliers and undo those. Then we can remove this whole top, which is quite useful in a lot of ways. Let's just see if we can. Well, that's not too bad. Let's have a go. Trying to get them in the right place. I'll catch up with you in a minute. There we go. Okay, I'm just going to show you on the board the markings. So I'm just going to grab hold of the camera and let's turn this around. Oh, perhaps we can block it up. This is a huge lump of aluminium. Right. Let's just zoom down on that. There's the AC in. As you can see, right hand side AC live, left hand side AC neutral, and then we're coming across here. We've got something blue somewhere. Where are we? Okay, there we go. That there is a DC positive, and that there's a DC negative, and then down here that there's a DC negative, and that there's a DC positive. Okay, so that's simple enough. So then we've got a few screws. Just zoom out. 1, 2, 3, 4, 5, 6, and they're a torque. And is it this one? No, it's not that one. Are we sure it's not that one? Oh, it's gone. So I'll just undo those and then remove this ribbon here. There we go. I've also removed an earth. One interesting thing, look what we've got here, our old friends, the Zettler relays. So if they just switch in the AC side, then even if this inverter is duff, it's worth keeping for those. Although apparently they're only £5 or £6 each. But yeah, waste not, want not. So I'll just undo these screws. So that's those screws undone. Yep, there we go. Now, have we got any burnt bits on the bottom of those relays? We don't. Okay, that's interesting. I can't actually see any burnt bits on any of this. And if you remember on the Aurora 3.6 kilowatt solar inverters, it's the power connections to these relays that burn out, but these look perfect. There's no sign of any heating or anything, so let's just put that to one side. Then we've got this. We'll just remove this bit of plastic. There we go, the insulation, and then we've got a piece of tin here. So we just need to, there's a slot headed screw and there's a hex headed screw, and there's a couple of screws missing. So that's sort of interesting. Somebody's been in here before. Right, let's get the right screwdrivers for these. So did somebody have it apart and fix it, or did somebody have it apart and then try their best to put it back together, but forgot some screws and picked up the wrong one and all those sorts of things? So right, okay, that comes off. Aha! Let me zoom down on that. Yep, I can see black. Okay, so what have we got here? We've got some screws that hold the FETs down, or a clamp to hold the FETs down, and we've got these upstands. So I'll just remove that lot. I'll just do the first clamp on those. What are they? They're torques, small torques. Right, so that is a clamp, and there's the FET, and it's damaged. I don't think we need to take the rest of this board off, because I've got some examples. That one's damaged. That one's all cracked on the top. Why is this so familiar? And so's that one. We'll just zoom down on that. Right. I'll just undo those upstands and lift that board. So just remove that one. That's it. Undo that. Unplug that. Ah, there's some more. There's another couple there. Is that the right one? There's a couple of screws here. Hiding. That's really blowing quite well outside. If it gets any more, I'm going to switch the turbine off. Is that enough? Anything? Oh, there's one in the middle. Now, is that it? Ah, of course. We have to undo these clamps here. There we go. That's all the clamps. That's it. Oh, sticky. Right, let's zoom out. Okay, so. Ah, that's interesting. We need to zoom down on that. If we can. Well, all those FETs there don't look too bad, but we don't know. But these ones here are definitely a bit troubled. Okay. This one here, that leg, well, I think that's a diode, because that is connected to that and that's burnt off. That one there is 3 legs, so that must be a FET or something like that. That one there, again, looks like a diode, and that's got 3 legs. But they're all very damaged, as you can see. Yeah, can you see that? There, all the tops chipped out and everything. And again, on the other 2 lots, on the other 2 inverters, same damage here. Now, I suppose you could take these out and check each one for functionality, but you do know that all these are duff. So what's caused these, and are these the drivers for those or not? And in which case, if they're the drivers for these, then have these had a spike up them, and therefore the gate, I think it's the gate, I can't remember, are they all duff? It's a bit of a rabbit hole, and also we've got a bit of damage on a track there. But where are we? From the front it doesn't look too bad. I'm going to put the numbers of these diodes up here and what have you, if I can get a number off one of the other ones. So just give us a second. This is a different inverter, and interestingly the diodes have been removed from this one. Yeah, and one of the FETs. So I'm just going to see if I can zoom down really quite closely on that remaining FET there, because it does seem like it's in, well, the top's not burnt. So let's just see if we can get an image of that top there. There you go, and it's 3 legs. So this is the one remaining good diode. September, oh no, DSEP30, that looks like it. Q6A. Right, anybody knows about those? Be interesting. All 3 of them awaiting inspiration. The boards, as I said, will contain those Zettler relays, worth keeping. It just seems a shame that such a huge amount of embedded energy has been destroyed through, I can only guess at overpowering these. Instead of fitting 2 in parallel and taking the load from a turbine, yeah, they've just had 1. And of course when it's really windy, the turbine's giving it what for, then everything's going to get hot. So an interesting fact on top of that is, if you remember the video where they were lowering that 6 kilowatt turbine, I'll probably put a link and then you can see it again. Anyway, I looked at all the control gear in there, in the box associated with it, and there was no dump load. So effectively what the fitters had done is they totally relied on the vary pitch blades to control over speed of the turbine and also control over volts. Well, I really think that you could do with a dump load across the 3 phases of the turbine before it gets to the rectifier. And that's what I've done on our Proven. If I want to switch it off, I flick a big switch, or I wait for a lull in the wind, flick this switch, and then there's a very small resistance put across each phase. So 1 to 2, 2 to 3, and 1 to 3. And that stops the turbine. And then I can put a dead short across it. Well, if they were to have some voltage sensing board, for want of a better word, that operated the dump load, then in over volts or over current or what have you situation, then the dump load would come on, and it wouldn't stop the turbine, but it would share the load, so therefore take the stress off the inverter. And again, I've done that on our Proven, so that it diverts 20 amps into a heating element, and that's on the DC side. So there you go. You know, I think it's down to fitting these things as cheap as possible, trying to get away with it, and they probably do get away with it for 5 or 8 years. But you know, you fit a turbine, there's a huge amount of embedded energy in the steel, the galvanizing, the fitting, all the electronics. So why put it at risk for short-term competition and a race to the bottom philosophy? Up to a standard, not down to a price, if you want things to last. I will catch up with you soon. Cheers for now.